anybody yet.
Okay.
Okay. First, I should probably go with like getting to the right place first, huh? Like 11:05. This will be exam 3 coming up, which I already have 4.1 done. So let's not do that. Let's do a new page and call this 4.1. All right, so we're going to talk about 4.1, which is exponential functions. It'd be great if I can spell all at the same time as well, but it's not always so nice. All right, so first of all, exponential functions. What is an exponential function? You guys seen these before. It's where f of x is equal to b to the x. Which also means it's y is equal to b to the x. Oops, not squared, x. So b can be a number, can be anything it wants to be. All right, 9 times out of 10, it's just going to be numbers raised to the x power. Okay, so obviously we're going to talk about things from chapter 3, which was talk about transformation as well, right? So essentially, when we talk about transformations, we're going to use probably y is equal to b raised to the x minus h plus k. And the h, or I should say positive h, means I'm going to shift to the right, and negative h means I'm going to shift to the left. Positive k means I'm going to shift upward, and negative k means I'm going to shift downward. Are we okay with that? So the first thing they're going to ask you to do is to evaluate. So they might say, hey, given that f of x is equal to 42.2 times 1.56 raised to the x power, find f of 3. So what would f of 3 be equal to? What would you do? Everybody's just pulling their calculator. So you would what? Replace the x with the 3, right? So it'll be 42.2 times 1.56 raised to the third power, right? So what do I do first? Do I multiply first, or do I raise it to the power first? Okay, so remember that the first thing we would do is that we want to do this piece first. Okay, and the reason is because of order operations. We would do exponents before we multiply. So what does f of 3 come out to be? F of 3? 1.56 to the third, and then multiply by 42.2. So 160.21. Are we okay with that? Pretty easy? Okay. So if I gave you an equation like, I don't know, that g of x, let's talk a little bit about transformations right now. So let's say g of x is equal to 3 raised to the x minus 1. What happens to my graph? Shifts to the right 1. Now, if you remember correctly, I come back up here and notice that what I wrote up here is b raised to the x minus h. And if the h was positive, which in this case it was positive 1, it would move to the right 1. Everybody see that? We're good? Are we okay with that? How about if h of x what does that do? Okay, so we're going to shift left 1 and excellent. Oops. That's probably don't like. Do we have any questions on that? Nada? Okie dokie. All right, so the question is, what does this graph actually look like? How do I want to do this? Because every time I shift colors, it shifts, it changes what I just wrote down to that color. And it's just like, no, don't do that. Okay. So first of all, I wish I can draw these curves not free-handedly, but it's going to have to be now. So this is still f of x is equal to b to the x, but the b is greater than 1. And this graph here is still, whoa, that's really thin. It's still equal to b to the x, but b is going to be between 1 and 0. And notice where it's always going to cross. Where's that going to be, do you think? Any ideas? Think about it. What's my x? What do we call that? We call that the y-intercept. So what do we know about y-intercepts? What equals to 0? The x is equal to 0, right? So if we plug in x equal to 0, we get b raised to the 0 power. What's b raised to the 0 power? What's anything raised to the 0 power? Try on your calculator. Make up a number, raise it to the 0 power. Huh? No, it does not. Try again. Listen to William. Or try on the calculator just so you know. So you're telling me that the x value is 0 and my y value is 1. Does that make sense? Are we okay with this? So if you notice, both lines start to curve downward and it goes towards the x-axis. And it's always going to get closer and closer to the x-axis, but it's actually not going to cross the x-axis. What do we call those? So the two curves, you know, it gets closer and closer to the x-axis, but it doesn't actually cross the x-axis. We call that something. It rhymes with Pamela-pope. Oh, it's an asymptote. Huh. You guys are so good. So, you guys are so fast. So, so both graphs has a horizontal asymptote. Apparently, I decided to call it Toto. Of y is equal to 0. Are we okay with that? Yes? Okay. So we're going to talk about something that's going to be used very often, and it is the number e. E is approximately 2.71 ... It just goes on. It's an irrational number. It just goes on forever and ever 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 and ever. Okay. E, oops, is known as a natural base. So therefore, f of x is equal to e to the x is known as the natural exponential. Can't spell. Or in this case, write. Function. Most likely you will see this mostly in like compound interest type things, okay? So that means we're going into interest. So let me write that as a title here, compound interest. So with compound interest, you guys have known of this formula. A is equal to P times 1 plus R over N, all raised to the NT power. My question is, do you know what all of it stands for? What does the P stand for? This is compound interest. So we're talking about dinero. We're talking about money. We're talking about, so when we talk about compound interest, we're talking about like investing principal. Its principal is with LE, right? Because principal, I think it's like pal, as in like person. I believe. I can fly. I believe. I can touch the sky. I think about it every night and day. What is R? The rate. But this rate is special. It's not just rate. It has to be in what form? No, not percent. A decimal. So it's not going to be a percent. We're going to have to change the percent to decimal. So we're going to move the decimal point twice to the left. What is T? Time. And typically the time is in years. What is A? What amount? The end amount. Excellent. We have one letter left. The N. What's N? In a year. So number of times compounded in a year. So let's talk about some N stuff. So if I say semi-annually, what's N equal to? Huh? Not 1/2. So if semi-annually means what? Half a year. So in 1 year, how many times did that happen? 2. Does that make sense? I guess I should have started with annually, huh? How about annually? N is equal to 1. How about quarterly? N equals 4. How about bi-monthly? I think I hear it. 24? 12? Anybody else? Bi-monthly? 6. Yes, once every 2 months. So monthly would be what? Are we getting the gist of N? Okay. So this is basically compound interest that's compounded annually, semi-annually, bi-monthly, monthly, right? There's a term that is telling you how often it's compounded, so you know how many times it's compounded in a year, okay? So let's talk about student loans. Student loans are compounded wow. So like student loans is compounded continuously. So there's no like, basically like n is like infinity. With that being said, obviously I'm not going to raise something to infinite power and it's just going to be ugly. So what that is going to do is it's going to give you a totally different formula. It's P times E raised to the RT. Now, for you guys, I don't know if you guys still have this shampoo, but back in my day, we had a shampoo called Pert. And that's how we remembered it. But I don't know if Pert is still out as a shampoo or not. It is? Yeah, it is green. So that's how I remember it. Are we okay with that? So I know that I've given you a bunch of information and not a lot of examples, but like the evaluation is kind of self-explanatory, but I wanted to warn you guys more about the fact that we have to raise it to the power before we multiply it by anything. Does that make sense? So we got to remember that. All right. So let's see here. I have two examples here. It says that $10,000. It says $10,000 is invested in an annual rate of 8%. Find the balance of the account after 5 years. Subject to a quarterly compound. All right. So if you notice that, I know you guys love word problems so much. That if you guys notice that as I read, I pulled out 4 pieces of information. Okay. So what is the 10,000 stand for? Is that the end amount? Because doesn't this ask you for find the balance in the account, right? So at the end of 5 years. So that would be the end amount, would be end of 5 years. So this would be, and the key word is that I'm investing $10,000, right? Okay, principal is usually the starting amount. Yep. Yep. 8% is my rate, but I can't use, I'm not using 8%, I'm using 0.08. 5 years is my T, and Corley says what? N is equal to 4. Awesome. Let's plug it in. So my formula is A is equal to P times 1 plus R over N raised to the NT power. So A is equal to 10,000 times 1 plus 0.08 divided by 4 raised to the 4 times 5. Now, if you guys plug this correctly in your calculator, it will come out Question is, do you know how to plug this correctly in your calculator? The iPhone will probably not work very well. Oh, Desmos, you're going to try to use Desmos? Good idea. If you do plug this in your calculator, you need a few extra parentheses, per se. Do, 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 do. Do, 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 do. Do, 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 do. You got the scientific and you got the graphing. But if you want to use on a test, use test mode because it has all three in there. There's a blue one that's called a test mode. You got 14,000. That's important.
Where did you need the extra parentheses? I mean, I did it two different times, but one original and one with the extra parentheses.
The 4 times 5 should be in this. Oh, because your calculator, when it raises, it doesn't toggle over. That's why. Some of theirs don't toggle, don't throw the number up top. Okay. That's why. So this is not too bad, huh? Right? It's pretty good. If you put in $10,000 at 8%. Right? But think of this the opposite way. Think of this the opposite way. So let's say, because this works the same way if you are asking for a loan, right? So let's say you buy a car at $10,000, right? Typically, we make a 5 or 6 year plan on that. Let's say a 5-year plan. And the rate is 8% and it's compounded quarterly, right? So that $10,000 car that you bought, at the end of 5 years, because of the interest rate, because of being compounded quarterly, you actually paid almost $15,000 for the car. Does that make sense? So understand that it works the same way of investing money, because really the $10,000 that you're asking for a loan, you're really investing, but it's the bank investing in you so that they can get another $5,000 out of it in 5 years. I can't say it's too bad because I'm basically getting $1,000 free every year. That's pretty good, right? So think about that. Now, think about investment wise, because for you guys, some of you guys are still young enough to start investing. Think about this. Not saying that you have $10,000 to put in. Heck, start with 500, right? Because basically you made half of it back. So let's say you use 500, right? You get 250 back. Yeah, not a great amount, but still 250 of free money. Then invest that whole thing back in. So now you're at 750. Invest that back in. You get half of it back. Invest that whole thing back in. Get half of it back. Invest the whole thing back in. You get half of that. You know what I'm saying? So it's just gonna. So that's why you want to roll things over so that you can make more money at the end. Because your concern isn't about, can I use this money when I am 25? It's more about, when I retire, do I have a nice nest egg so that I don't have to work anymore, right? I can just take a trip to Spain and not worry about, crap, we're going to have to eat, crickets on the side of the road so that we can make this trip happen. Does that make sense? So think about that, all right? Any questions?